Hello and welcome back to our Arduino Python series. In today's tutorial, we are going to combine two cool output devices, a servo motor and a buzzer, and control them directly from Python using keyboard presses. We will be using the same Python Moto 2 library that we have been using throughout the series, and we will also introduce a new library called keyboard to detect key presses on your computer. So by the end of this video, you will know how to set up a servo and a buzzer on an Arduino, but you already know this, but we're gonna just explain it again a little bit more. Next, write Python code that moves the servo to a specific angle when you press keys. And the third one, make the buzzer beep whenever the servo moves beyond 90 degrees or whatever degree you tell the program. So this is a great way to see how you can add sound and motion to your projects, all controlled from Python. So let's dive in. First, let's quickly go over the components you will need. An Arduino board. I'm using an Arduino Uno, but you can use other boards. It's completely the same. A servo motor, just any standard servo like the SG90. A passive or active buzzer. I'm using an active buzzer that beeps when power is applied. Jumper wires and a breadboard if you have. It's completely optional, but it's very, very handy. Okay guys, let me show you how you can set up the hardware. Okay, this is our buzzer again, so you know how to set it up. So see, the long leg is the positive, and if you see here, you can see the positive sign. Okay, we're gonna connect it like here. Okay, and now we're gonna just take two wire. So we're gonna connect it from here, and we're gonna connect it from here. Okay, so this leg, the small leg, it goes to the negative, and here the pin number 8 on our Arduino board, I'm gonna connect it here. Okay, so this is our buzzer and our servo. So as you know that the servo has 3 wires. So the brown one goes to the negative. I'm gonna use, for example, like here. See the negative of the breadboard. So the brown one goes to the negative. The red one will go to the positive. Sorry guys about the color of the wires, because I didn't have the exact color like the servo itself, but I am explaining to you from here. So the red, this one, the middle one, the red one, goes to the positive of our breadboard. Here you can see the positive, and the orange or the yellow one, okay, the orange one, it will go to the pin number 9. If you can see, number 9 is PWM, or pulse width modulation. So I'm gonna connect it here, and I'm gonna connect the 5 volts of my Arduino. 5 volts, it goes to the positive, and see the GND. The GND, there's 2 pins of GND. I'm gonna use one of them, and the GND goes to the negative. Okay, so this is the hardware. So we just finished setting up the hardware, and we can start coding. Okay guys, so before we start writing the code, we have to make sure that we installed all necessary libraries. So we have Python Moto 2 installed already, because we used it in previous lessons, but today we're going to use another new library. It's called keyboard. So you have to install the keyboard library first. So in order to install the keyboard library, you have to open your terminal. Okay, let me show you how you can, if you're using the Visual Studio Code, you can go to the view, and here you can see the terminal. Okay, so open the terminal and just type exactly this that I tell you, pip install keyboard, and press enter. Just pay attention to how I type it down. Okay, so requirement already satisfied. So because I have installed this library before, it says that, but if maybe you don't have this library, so it's going to show you a successfully installed library. That's all we need. Okay, now let's start coding. The first step is to create, a new file or folder, whichever you want. Okay, so you already know how to do that. I don't explain it anymore. I'm gonna call it, for example, like servo buzzer.py. Again, don't forget about this .py, guys. It's very, very important. The first step, as usual, is to import our libraries. The first library, I'm gonna say from Mata to import Arduino and util. And today we're gonna use also Servo, so we're gonna import it here. And again, our friend time library, and the new library that we installed just now, import keyboard. So this one from Mata to import Arduino util Servo. We import the main Arduino class to connect to our board, the util or utility module, which includes the iterator. We will see that in a moment. And the servo, which is a constant that tells the pin we want to use servo mode. Okay, so the next library is time. So this gives us the sleep function for creating delays. And this keyboard library, this is the library that lets us detect key presses. It works on Windows, Linux, and macOS. Okay, the next step is Arduino connection. We can say port. Again, I'm using COM9. Okay, I'm just doing it very quickly, guys, now, because you already know I explained it and I repeated it so many times, before, so I don't just do it again here. Okay, so we just here we set the port, whether our Arduino is connected, where our Arduino is connected. But just one more time, make sure that you change this, because yours is definitely different than mine. Now let's start the iterator. We're gonna say iterator equal util, using the utility libraries that we imported here. Okay, util that iterator, where we want to use it on our Arduino board. Okay, let's just start our iterator that start, open and close parentheses. Okay, so the iterator is a background thread that continuously reads data from the Arduino. It's required for handling input pins and also for some output features like callbacks. Even though we are only using outputs here, it's a good practice to start it, because we used to do it in previous lessons, so it's just a good practice, as I told you, to use it here. Okay, now let's set up the buzzer. We're gonna say buzzer pin. I'm gonna use pin number 8, and I'm gonna say board. At the beginning, I want the buzzer to be off. Board dot digital. Which port I'm using? I'm using the buzzer pin. Okay, dot right 0. Okay, so we assign the buzzer pin number 8 to a variable for clarity. Here, this is the variable, just for more clarity. And board.digital 8, gives us a reference to that digital pin. The dot right 0 sets its low. So ensuring the buzzer is off at the start. Remember, digital pins can output 0, it means low or 0 volts, or 1 means high or 5 volts. Okay, that's it. Okay, that's it for the buzzer. And let's just set up our servo. We can say servo, another variable. Sorry, servo. I'm going to call this variable servo. Okay, servo equal board dot digital pin. Which pin I'm using? Pin number 9. And I'm going to say servo dot mode equal to servo. Yes. And so this servo dot mode equals servo. It tells Python Mata that this pin should operate in servo mode, which automatically generates the correct PWM signals for servo positioning. Okay. And at the beginning, again, like the buzzer, isn't at the beginning we said we want the buzzer to be off? Here, at the beginning, we want the servo to be at the 0-degree position. How we can do that? We can say servo dot right, and we put 0 here. So it will move the servo to 0 degrees as an initial position. Okay. Okay, so we set up the buzzer and we set up the servo. Now it's time for the beep function. Okay, guys. Now we define a function called beep, and this function takes a duration argument in second. Okay, let's do it. I'm gonna say def beep. Okay, I'm gonna give it duration argument. Okay, and we want to turn the buzzer on by writing 1 to the buzzer pin. How we can do that? We can exactly do the same. We can copy and paste here. Just instead of putting 0, we can put 1. Okay, and here we want to wait a little bit. Time that sleep, we're gonna use this sleep function. We're gonna use our time library and this sleep function. We can say duration. Okay, and now then we wait for duration here. We wait for duration in seconds. And after that, we turn the buzzer off. How we can turn the buzzer off? Exactly like this, without change it at all. All right. And finally, we add a short delay, like let's say time that's sleep 0.1. This is just to separate, consecutive beeps a little, but you could just adjust it, instead of this 0.1, you can just adjust, whatever number you can put here. Now we have to define the keyboard control function. Okay. So we will go to the next line and we will start to define the new function. We're gonna call it like set servo angle, and we're gonna give it angle argument. Okay, so I gave angle as an argument. So this function takes an angle and moves the servo to that angle. How it can you do that? It will use this servo dot right angle. Okay, yes. So this function takes an angle, this one, it will take this angle and moves the servo to that angle. But how it do that? By this line, servo dot right angle. Okay. And we want to print the angle to the console, so we know what's happening. How we can do that? We can say print. Don't forget to use the f string, because we're not only using strings, we're using other things. Servo set to. Okay, I want to see the angle. angle, and at the end you can just add DEG, like degree angle. Okay, so servo set to this angle degree. Okay, then we want to check if the angle is, for example, greater than, like, say 90 degrees, because we want to start the buzzer. So how we can do that? We can say if angle, very easy, greater than 90, then what you should do, start the buzzer for how long? For, like, let's say 0.2, not too long. It's up to you, you know, you can say for 1 second, you can say for 5 seconds, or whatever you want. Okay, so this line, it check if the angle is greater than 90 degrees. If it is greater than 90 degrees, it calls beep 0.2 to make a short beep. Okay, so it's called this beep for how long? For this, we're gonna give it the duration. How much is the duration? The duration is 0.2. Okay, this is the second function. Yes, so we finish just this function. Okay, now we have to go to the next line. So first of all, let's just print a message for the user to tell them, for example, you know what I want to do? I want to say, for example, if the user, if the operator, or if anyone press 1, the servo goes to the 45 degree. If the user press 2, it's gonna move to the 90 degrees. If press 3, goes to 135, and if they press 0, the servo will return to the 0 degree. And if they press Ctrl C, it will exit from the program. This is the scenario that I want it to do. You can just, change it whatever you want, but this is only what I want to do. So it's not compulsory that you only have to do this. It's completely up to you. So I'm gonna say, okay, let me close. Okay, I'm gonna say press now I'm gonna use double quotes because I want to use the single for 1. Okay, press 1 to move servo to 45 degree also, and press and 2 to move to 90 degree. Press like 3 to move to, like, what did I say? Oh, I said 135 degree. Then I said press 0 to move to 0 degree. Okay, and press Control plus C to exit. Okay, this is the message that we want to show in the console first, to know exactly when we run the program. This is kind of, instruction for the user, so they know which keys to press and they know how the program gonna work. Okay, so it's not just, you have to use this line. No, it's just, as I told you, it's kind of an instruction. Okay, now it's time to just write the main loop. Okay, as usual, because you want to just use Ctrl C to interrupt the program and to exit safely, we use try and except. So try, and I'm gonna say while true is true. Okay, now I'm gonna say if keyboard that is this is press is a built-in function. Okay, so is pressed is a built-in function that it will returns true if that key is currently held down, because it checks the state of the key. We don't need to wait for an enter press. It's very immediate. Okay, so I'm gonna say if keyboard that is pressed is, like, say 1. Okay, then what it should do, it should set, what was the name? Set servo, yes, set servo angle, yeah, to 45 degree. Okay, and we need just to wait a little bit here. Okay, so let me just say for how, like 0.1, huh? Let's say time that sleep for 0.1. Okay, so this is for the button or the key 1. Okay, now let's go to the next key. For example, if they're gonna press 2, what we should use here now, because we have 3 or 4 keys, we have to use elif function. Okay, elif keyboard that is pressed, so if the key that the user gonna press will be 2. Okay, so what it's gonna do, it's gonna set servo angle. I'm gonna use this function that we used here, and now we're gonna give it the argument. So where it should go to 90, right? Okay, and again time that sleep for how long? 0.1 second. And again one more elif keyboard that is pressed, which key? Key number 3. Okay, 3. Okay, key number 3. Okay, so what it should happen, set servo angle to what? 135. Okay, and again time that sleep for how long? Again 0.1. Okay, one more. Again we're gonna say elif keyboard that is pressed, which key? Number 0. Okay, what's gonna happen? It's gonna set servo angle to what? To 0 degree. Okay, and again time that sleep for how long? 0.1. Okay guys, so we defined 1, 2, 3 and 0, exactly like what we defined here. 1, 2, 3, 0. Okay, and at the end of this, okay, now I'm gonna say time that sleep for how long, and now this time I'm gonna say 0.0. Okay guys, now let's just review a little bit more, what happened. So we wrap the loop in a try, see here, try, in a try block, so we can catch, as I told you, keyboard interrupt when the user presses Ctrl C to stop the program, like what we defined here. That's why we use try. Then inside the infinite while true loop, we check each key using keyboard that is pressed. Okay, we check by this. This function returns true, I told you, if that key is currently held down. So because it checks the states of the key, we don't need to press any other keys like enter, space, or anything else. It's immediate. When a key is detected, we call set servo angle. See, set servo angle. We call this function. So maybe you're gonna ask, maybe I can tell you, when we can use this function. This function gonna get called exactly the time that you press one of the buttons, 1, 2, 3 and 0, or Control C. So not Control C, sorry, just 1, 2, 3 and 0. Okay, so when a key is detected, we call set servo angle, this one, set servo angle, with the corresponding angle. After each command, we add a short 0.1 second delay here. Okay, This is a simple debounce to prevent the same key presses from triggering multiple times too quickly. Okay, as if you can remember in the button tutorial, I told you, the mechanical keys, the problem is that, they're bouncing, so we have to cancel this bouncing or debounce them. So we do it by this code. Okay, so without it, holding the key might cause the servo to chatter. Okay, so outside if-elif chain, we have a very short, see here, we have a very short time that slips 0.01. This prevents the loop from consuming 100% of your CPU by giving the system a tiny break. It's common practice in such polling loops, right? Yeah. So it prevents your CPU from overrunning. Okay, so now it's time to just write our except loop, except keyboard interrupt. Okay, so what we want to do? We want the servo to go to the 0 degree again. We can say servo that write 0. Okay. And we want the buzzer to just turn off, to go off. We can say board dot digital. Okay, which pin I was using, buzzer pin. Yeah, and I'm gonna say that right 0. You could exactly copy and paste this line, so I just typed it in again, so it's okay if you do that. And I want to exit from the program safely. I'm going to say board dot exit 0, open and close parentheses, and at the end just print a message for the user that the program stopped because they pressed Ctrl+C. Program, I'm going to say program stopped. Okay, so here in this except loop, so if the user press Ctrl+C, a keyboard interrupt, this function, this block, I mean, exception is raised, so we catch it here. Inside the exception handler, we move the servo back to 0 degrees, turn the buzzer off, and call board.exit to properly close the serial connection to the Arduino. And finally, we print a message so the user knows the program has stopped clearly. Guys, let's run the program and see how it's gonna work. Okay, I'm gonna press the run button. Okay, we're waiting to see what's gonna happen. Okay, still waiting. Oh, there's an error, guys. It says attribute error, pin object has no attribute, right? Did you? Oh, okay, I think I made a mistake, guys, here. Here, yes. Unfortunately, I just made a mistake. WRITE, that's correct. And unfortunately, I just copy and paste it here. Yes, and this here it's also wrong. Okay, and now it's okay. And what about the others functions? Okay, here it's okay, right? And here it's okay, right? Let's run the program again and see one more time. Okay, I pressed run button and I'm waiting to see what's gonna happen. Hope this time it's gonna work. Oh, okay, guys, so did you see that the servo moves at the beginning? It's because I told the program to move the servo to the 0 degree when I run the program. Okay, so it doesn't matter which position the servo is, just bring the servo to the 0 position. So that's why the servo moved. Okay, now we see the console. We are seeing the message. It says press 1 to move servo to 0.5 degree, 2 to move to 90 degrees, 3 to move to 135 degrees, 0 to move to 0 degrees, and press Ctrl C to exit. Okay, now let me press 1 and see. Oh, okay, see guys? So I pressed 1 and it moved to 45 degrees. Let's press 2. Yes, to 90 degrees. And if I press 3, the buzzer should start beeping. Yes. Did you hear? Let me press 2. It goes to the 90, and again 3. Yes. And if you press 3 again, just the buzzer start. See? Okay, now let me press 0. Yes. Oh, sorry. Yes, that's great. So just one more time, let me press 3. Yes, it goes to 135. Press 0, comes to 0 degree. And let me just check if our emergency button work. I'm gonna press Ctrl C. Yes, see the message, program stopped. Okay guys, our program working properly, and hope you enjoyed this lesson and you learned new things. Thank you for watching us again today. See you in the next lesson.